Antarctica may appear to be an immobile environment, a still, white landscape, but there's a lot more going on beneath the ice than we realize, even if you have to go to space to find out. The Antarctic Ice Sheet may appear to be a peaceful, permanent ice blanket that has blanketed Antarctica for millions of years. However, at its thickest, the ice sheet can be thousands of meters thick, concealing hundreds of meltwater lakes where its base meets the continent's bedrock. Welcome to today's video, where we will be discussing what was discovered by scientists under the ice of Antarctica and how it affects everything. Without further ado, let's get into it. Approximately 5,000 scientists visit the ice continent each year to examine the unspoiled region in order to learn more about the Earth's past and the consequences of climate change. Its arid nature provides them with a unique ecosystem in which they can finish their studies, despite temperatures as low as -90 degrees Celsius. Scientists at NASA have announced that they have discovered 2 new lakes buried beneath the Antarctic ice sheet. They form a part of a vast network of subterranean waterways hidden beneath 1.2 to 2.5 miles of ice. When scientists analyzed data from NASA's IceSat satellite, they discovered that fluctuations in ice elevation in West Antarctica reflected a massive amount of subglacial water movement beneath the ice sheet. Prior to the finding, it was thought that hidden meltwater lakes existed in isolation, shut off from one another at the bottom of the ice sheet where the ice meets the continental bedrock beneath. Researchers discovered in 2007 that variations in the height of Antarctica's surface ice indicated the flow of water between a hidden network of subglacial lakes, which alternately fill and drain before their water flows to the Southern Ocean. Now the IceSat-2 mission, which was launched in 2018, is giving scientists an even better look at this strange, deep buried lake network, as well as revealing 2 lakes that have never been discovered before. The key discovery from the IceSat mission was the discovery of these interconnected systems of lakes at the icebed interface that are moving water around, with all these impact on glaciology, microbiology, and oceanography, says glaciologist Matthew Siegfried of the Colorado School of Mines. After utilizing IceSat, IceSat-2 is like putting on your spectacles. The data is so much higher precision that we can begin to draw out the lake boundaries on the surface. In a new study, Siegfried and colleagues gathered altimetry data from IceSat-2 and the original IceSat mission, as well as measurements from the European Space Agency's Cryosat-2 ice-observing satellite ESA. The researchers were able to monitor active subglacial lakes at periods shorter than IceSat-2's repetition cycle by integrating the records, which span the years 2003 to 2020, the 91-day gap before it can observe the same region again. Surface deformation due to active subglacial lakes filling and draining provides one of the few remotely accessible windows into the evolution of basal water systems. These systems are otherwise hidden beneath up to 4 kilometers, 2.5 miles of ice, and remain one of the major physical uncertainties on projections of future ice sheet dynamics. By capturing denser and more exact geographical detail, IceSat-2 laser altimetry can not only expand the record of subglacial lake activity, but also provide a deeper understanding of hydrological processes. The research discovered 2 anomalies that appear to be hidden lakes previously undetected, in addition to providing a more thorough look at the activity and outlines of known subglacial lakes in Antarctica, of which there are over 130 currently documented. These potentially active lakes, known as Lower Conway Subglacial Lake (LSLC) and Lower Mercer Subglacial Lake (LSLM), are located near previously found lakes and could have been missed by the original IceSat mission due to the small gaps between observations. The lake system, which is dominated by 2 huge active subglacial lakes, Conway Subglacial Lake and Mercer Subglacial Lake in this location, underneath the Mercer and Whillans ice streams in West Antarctica, looks to be in the midst of its 3rd drainage episode since IceSat observation began in 2003. A parallel study co-authored by one of the same researchers involved here, glaciologist Helen Fricker of the Scripps Institution of Oceanography, detailed a dramatic lake drainage event in East Antarctica, where a surface lake atop a floating ice shelf vanished in a matter of days. Water flowing from the subglacial lakes in West Antarctica is likewise assumed to eventually flow into the ocean. However, the hidden escape route is far more difficult to picture. These are processes that are going on under Antarctica that we wouldn't have a clue about if we didn't have satellite data, Fricker says. We've been struggling with getting good predictions about the future of Antarctica, and instruments like ICESat-2 are helping us observe at the process scale. Also, NASA scientists made a stunning find after drilling beneath the ice of the continent, discovering the first glimpse of life hidden for millennia. Dr. John Priscu led a team of researchers through the overlaying ice sheet to examine the waters of a planned lake hidden beneath the Antarctic Ice Sheet after more than a decade of planning. During a TED Talk, he described how the breakthrough came to be. He said, "We joined up with NASA, and using satellite images, we could see flat spots all over the continent, and this is where the ice sheet floats over these lakes. That was our first impression of these lakes, so we count them up, and we know there are some huge lakes out there. It's not just this big block of stable ice. We also, using satellites, can see the surface of the ice going up and down by measuring the satellite altimetry over time, and we can define rivers flowing underneath the ice sheet. We have all this indirect evidence and beautiful river systems like you would see coming out of the Rocky Mountains." Dr. Priscu revealed the difficulties of getting to the South Pole to investigate the area they called Lake Williams. He added, "So we went out to this Lake Williams area, and the first problem is you've got to get a lot of stuff to the middle of nowhere." NASA scientists discovered a swimming shrimp-like organism 600 feet beneath the Antarctic ice, where no light can be seen, challenging the premise of where and how forms of life may persist. While the creature is just around 3 inches long, it has the potential to have a huge impact. According to a NASA document, a NASA team was lowering a small video camera to acquire the first ever shot of the underside of an ice shelf when they noticed the swimming creature. The discovery has the potential to change the way that we think about what kinds of organisms can thrive in different environments. "We were operating on the presumption that nothing's there," NASA ice scientist Robert Benshadler told the Associated Press. "It was a shrimp you'd enjoy having on your plate. We were just gaga over it," he told the AP. The organism, a Lysianacid amphipod, may pave the way for larger excursions into harsher settings where scientists previously believed life could not exist, both on Earth and on frozen moons in space. So let us know what you think about the new discovery under the Antarctica ice down in the comments section, and remember to leave a like and subscribe to this channel for more interesting videos like this. Turn on your post notifications and stay tuned so you don't miss any updates from us. Until next time.